Hello, in this lecture we will find the area of the green circle. In the drawing we have triangle ABC, side AB of triangle ABC equals to 13 units, side BC equals to 15 units, and side AC of triangle ABC equals to 14 units, and inside the triangle we have a circle. Actually the green circle is inscribed in triangle ABC, and side AB of triangle ABC is tangent to the circle at this point. We will define this point as point D. Point D is the launch point between tangent AB and the green circle. And point D is the point of tangency between tangent AB and the green circle, and also side AC is tangent to the circle at this point. We will define this point as point E. Again, point E is the launch point between tangent AC and the green circle, or it is the point of tangency between tangent AC and the green circle. And side BC of triangle ABC is tangent to the circle at this point. We will define this point as point F. Again, point F is the launch point between tangent BC and the green circle. Okay? And we want to find out the area of the green circle. Okay? So, first of all, we will find out the area of triangle ABC, and we will define a new term that is called semi-perimeter or semi-perimeter of a triangle. Semi-perimeter So what is semi-perimeter? Semi-perimeter is actually the perimeter of triangle. Actually, if we have triangle ABC, and we know that size AB, the size of side AB is A, the size of side BC of triangle ABC is B, and the size of side AC of triangle ABC is C. Then the semi-perimeter of this triangle is the sum of its sides, that is the perimeter of triangle ABC, over 2. So it is actually A plus B plus C, that is the sum of the sides of triangle ABC, over 2. Okay? So the semi-perimeter of any triangle is defined as the sum of its sides or the perimeter of the triangle over 2. And the semi-perimeter is defined as S. S is the semi-perimeter of the triangle, and it is equal to the sum of its sides, that is A plus B plus C, over 2. Okay? So S, the semi-perimeter of this triangle, that is S, equals to A plus B plus C over 2. So we actually can find the semi-perimeter of our triangle ABC, according to the formula of the semi-perimeter, that is actually S, that equals to the sum of its sides, that is actually we will define side AB of triangle ABC as A, that is to say the size of side AB of triangle ABC equal to A units, and we actually know that AB, that equals to A, equals to 13 units, and we will also define side BC of triangle ABC as B. We know that BC equals to 15 units, so B equals to 15 units, and we will define side AC of triangle ABC as C, that is to say AC equals to C, and AC equals to 14 units, therefore AC that equals to C equals to 14 units. Okay, so actually the semi-perimeter of this triangle ABC equals to A plus B plus C over 2. That is actually the sum of triangles ABC sides over 2. Okay, so the semi-perimeter of triangle ABC will be equal to the sum of its sides, that is actually A plus B plus C over 2. And we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units over 2. So actually the semi-perimeter of triangle ABC equals to 13 plus 15 plus 14 over 2. So 13 plus 15 is 28, and 28 plus 14 equals to 42, and 42 over 2 is 21. So I write it down. So actually the semi-perimeter of our triangle ABC equals to 21 units. Okay? Again, the semi-perimeter of our triangle ABC equals to 21 units. And after we know that the semi-perimeter of our triangle ABC is 21 units, we can find the area of our triangle ABC according to a special formula. Usually we have the formula that of the area of any triangle, that is the base of the triangle times the height to the base over 2. That is the usual formula of the area of any triangle, but we will use a special formula for the area of any triangle in order to find the area of our triangle ABC. So the area of any triangle, A is the abbreviation for area. So the area of any triangle equals to the root of S is the semi-perimeter of the triangle, times S minus A. A is the size of one of the triangle sides, times S minus B times S minus C. Okay, so that is the formula for the area of a triangle. Okay, so we will use this formula in order to find out the area of our triangle ABC. Okay, the special formula that we will use in order to find out the area of our triangle ABC is this formula. We have already found out that A is the semi-perimeter of our triangle equals to 21 units. And we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. And we will find out the area of triangle ABC, our triangle, according to this formula. So the area of triangle ABC will be equal to the root of S is the semi-perimeter of our triangle. We know that S, the semi-perimeter of our triangle, equals to 21 units. It is S times S minus A is 21 minus 13. times S minus B. S minus B is 21 minus 15. And S minus C is 21 minus 14. So the area of our triangle equals to the root of this expression. 21 minus 13 is 8, 21 minus 15 is 6, and 21 minus 14 is 7. So I will write it down. So the area of triangle ABC will be equal to the root of 21 times 8 times 6 times 7. Okay, so that is the area of our triangle ABC. It is the root of this expression, and the outcome of the multiplication of this expression is actually 7056. So the area of triangle ABC equals to the root of 7056. And the root of 7056 equals to 84 square units. So we actually found out that the area of our triangle equals to 84 square units. So in the next step we will find out the radius of the green circle. Okay. So first of all, we will define the center of the green circle as point O. Again, point O is the center of the green circle, and then we will connect together points A and O by a straight line. And we will also connect together points B and O by a straight line. And we will connect together points O and C by a straight line. So actually we created here three small triangles, triangle AOB, triangle AOC, and triangle BOC, and the sum of those three small triangles equals to the sum of the areas of those three small triangles equals to the area of the big triangle, triangle ABC, because of the fact that triangle ABC contains exactly those three small triangles, triangle AOB, triangle AOC, and triangle BOC. So in the next step, we will draw three radiuses that starts from the center of the circle and touches the launch points of the circles that are D, E, and F. So the first radius starts from the center of the circle and touches the circle at point D, that is the launch point between tangent AB and the circle. Small r is the radius of the green circle, so this radius actually is drawn to the launch point, point D, and it actually touches the launch point, point D. And we will draw the second radius from the center of the circle to point E, that is the launch point between tangent AC and the green circle. Again, this radius is also drawn to the launch point, point E. And we will draw the third radius from the center of the circle to point F, that is the launch point between tangent BC and the green circle. Okay. And then this radius is drawn to the launch point, point F, and it touches the launch point. Okay? And we have a rule, I will call it rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to the launch point. So I will read rule number 1 again. Rule number 1 states that a tangent to the circle is perpendicular to the radius drawn to the launch point. So actually rule number 1 states that if you draw a radius that is drawn to the launch point, then that radius will be perpendicular to its tangent. For example, this radius is drawn to the launch point, that is point D. Actually, it touches the launch point. Therefore, according to rule number 1, this radius is perpendicular to its tangent AB. That is to say, this angle is 90 degrees and this angle also is a right angle. Okay? And the same thing is about this radius. This radius is drawn to the launch point, that is point E. Actually, it touches the launch point. Therefore, according to rule number 1, this radius is perpendicular to its tangent AC. That is to say, this angle is a right angle and this angle also equals to 90 degrees. Okay? And the same thing we can say about this radius is drawn to the launch point, that is point F. Actually, this radius is drawn to the launch point and it touches the launch point, point F. Therefore, according to rule number 1, this radius is perpendicular to its tangent BC. That is to say, this is a right angle and this angle is also equals to 90 degrees. Okay? So, as I have already mentioned, the sum of the areas of triangle AOB plus the area of triangle AOC plus the area of triangle BOC equals to the area of triangle, the big triangle ABC, because of the fact that triangle ABC contains exactly those three triangles. So we will create an equation, an equality that states that the sum of the areas of the three small triangles equals to the area of the big triangle, triangle ABC. Okay, so again, the sum, the area of triangle ABC, that is equals to 84 square units, equals to the sum of the areas of the three small triangles, the area of triangle AOB, plus the area of triangle AOC, this triangle AOC, plus the area of triangle BOC, this triangle. Okay, the area of the big triangle ABC, that equals to 84 square units, equals to the sum of the areas of those three triangles. Again, because triangle ABC contains or composed exactly from these three small triangles. Okay, so what is the area of triangle AOB? The area of this triangle equals to the base of the triangle, that is AB, times the height to the base. The height must create 90 degrees with the base AB, so you can see here that the radius creates 90 degrees with the base AB. Therefore, the radius is the height of triangle AOB. So it is times the radius the base AB times the radius over 2. So the area of triangle AOB equals to the base AB times the height, that is the radius, over 2. Okay, and what is the area of this triangle, triangle AOC? The area of this triangle equals to the base of triangle AOC, that is AC, times the height to the base. The height must create 90 degrees with the base, therefore the radius creates 90 degrees with the base, therefore the radius is the height of triangle AOC, so it is the base AC times the height, that is the radius, over 2. So the area of triangle AOC equals to the base of triangle AOC, that is AC, times the height to the base, that is the radius, over 2. And the area of this triangle BOC equals to the base of the triangle, that is BC, times the height to the base. Again, the height must create 90 degrees with the base, and as you can see from the drawing, the radius indeed creates 90 degrees with the base, therefore the radius is the height of triangle BOC. So it is the base BC times the height to the base, that is the radius, over 2. So the area of triangle BOC equals to BC to the base BC times the height to the base, that is the radius, over 2. Okay, and what is the value of AB? You can see here that AB equals to A, so we substitute AB by A. And what is the value of AC? AC equals to C and what is the value of BC? BC equals to B so we found out that 84 equals to this expression. Here we will take R over 2 as a common factor of this expression, so we'll take out R over 2 as a common factor. Okay. (84) equals to R over 2 is taken as a common factor. So in the brackets we left with A plus C plus B. So in total we got that 84 equals to R over 2 times A plus B plus C. But we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units, so I will write it down. So we got that 84 equals to R over 2. In the brackets we have 13 plus 14 plus 15, so 13 plus 14 is 27, and 27 plus 15 is 42. So I write it down. So we got that 84 equals to r over 2 times 42. 42 over 2 is 21, so I'll write it down. So we got the equality that states that 84 equals to 21r. Here we will divide this equality by 21 in order to get the value of r. So r equals to 84 over 21, and 84 over 21 is 4. So we found out that the radius of the green circle equals to 4 units. Okay, the radius of the green circle equals to 4 units, and the area of any circle equals to pi times the radius of the circle squared. The area of a circle equals to pi times the radius of the circle squared. Okay, we'll calculate the area of the circle according to this formula. We know that r equals to 4 units, so we will substitute r in this formula by 4, and we will get that the area of the green circle equals to pi times r square. R is 4, so r square is 4 square. So we got that the area of the circle equals to 16 pi square units of the area of the circle in terms of numbers. Will be equal to 50.265 square units. Okay, the area of the green circle equals to 50.265 square units. So I'll repeat again that the area of this green circle equals to either 16 pi square units, or in terms of numbers it equals to 50.265 square units. So in the next step I will present a second method to find out the area of triangle ABC. Okay, a second way to find out the area of triangle ABC. Okay, I will present a second method to find out the area of triangle ABC. Actually, we will use the law of cosines in order to find the area of triangle ABC. So, what is the law of cosines? Before I explain to you what is the law of cosines, I must emphasize that the law of cosines valid in any triangle. It can be used in any triangle. So I will write that in any triangle so if we actually have triangle ABC, it can be any triangle, not necessarily our triangle, but any other triangle. So if we have this triangle ABC and we know that side AB equals to A units in size, side BC equals to B units in size, and the angle between side AB and side BC is theta, and side AC of triangle ABC equals to C units, then according to the law of cosines, the following equality is true in this triangle: C squared, that is C squared, equals to A squared plus B squared plus B squared minus 2 times A times B times cosinus theta. So C squared equals to A squared plus B squared minus 2 times A times B times cosinus beta. So we can implement the law of cosines in our triangle ABC, because I will draw triangle ABC again. So this is our triangle ABC, and actually, as you can see here, we have the size of all the size of triangle ABC, and the only missing variable is actually angle theta. So by solving this equality, we will find out the value of cosinus theta, and then we will find out the value of theta, and then we will find out the height of this triangle. And as you know, the base times the height over 2 equals to the area of any triangle, and especially it is true for triangle ABC or a triangle. Okay, so let's start. So we will use this equality in order to find out the value of cosinus theta. C square, C equals to 14 units, so C square is 14 square. 14 square is 196, equals to A square. A equals to 13 units, so A square equals to 169, minus 2 times A times B times cosinus theta is minus 390 cosinus theta B square is B equals to 15, so B square is 15 square, and 15 square is 225. Okay, so this is what we got from the law of cosines. And here 169 plus 225 is actually 394. So we got this equality. (196) equals to 394 minus 390 cosinus theta. Here we will subtract 196 from this equality. We will get that 0 equals to 198 minus 390 cosinus theta Okay, we subtracted 196 from this equality. Okay, and 394 minus 196 equals to 198. And here 390 cosinus theta left as it is. 196 minus 196 is 0. Here we will add 396 to this equality. We will add 390 cosinus theta to this equality. Okay, we added 390 cosinus theta to this equality. So here we will divide this equality by 390 in order to get the value of cosinus theta. So we got that cosinus theta equals to 198 over 390, and this is actually equals to 0.507962. Okay, so we found out that the value of cosinus theta is 1.547962. Okay, and we actually want to find out the value of theta. So we know that cosinus theta equals to 0.547962, and we want to find out the value of theta. In order to find out the value of theta, we will operate the inverse function of cosinus on 0.547962 in order to find out the value of theta. Okay, so the inverse function of cosinus is arc cosinus, and we will operate the inverse function arc cosinus on the outcome, that is 0.5079662, and arc cosinus of 0.547962 equals to 59.49 degrees. So theta equals to 59.49 degrees. Okay, we found out that theta equals to 59.49 degrees. So after we know the value of theta, it is very easy to find out the area of triangle ABC, because actually we have the sides of triangle ABC and also the size of angle theta. So we will find the area of triangle ABC easily. Okay, here we have triangle ABC, we know that the angle between AB to BC, that is theta, this angle theta equals to 59.49 degrees. So in the next step, we will draw a perpendicular to side BC of triangle ABC. This is a right angle, and this angle is also a right angle. So actually, we'll call to AD, this point is defined as D. We'll call to line segment AD the height of triangle ABC. As you can see, AD creates 90 degrees with side BC. Therefore, if BC is the base, then the height to the base is indeed AD, because it creates 90 degrees with the base BC. Okay, so the area of any triangle and triangle ABC especially equals to the base of triangle ABC times the height to the base over 2. So the height of any triangle, and especially triangle ABC, equals to the base of triangle ABC times the height to the base over 2. As you can see from the drawing, the base is B, that equals to 15 units, times the height to the base. Again, the height AD creates 90 degrees with the base, therefore the height is indeed AD, that is H. Okay, so AD is the height, that is H, over 2. So the area of triangle ABC equals to 15 times H over 2. The area of triangle ABC equals to the base, that is 15, times the height, that is H over 2, but we must find out the value of H. As you can see from the drawing, triangle ABD is a right triangle because of the fact that this is a right angle. So in triangle ABD, it is a right triangle. Sinus 59.49 degrees equals to H over A. Okay, sinus of 59.49 degrees equals to H over A. So first of all, sinus of 59.49 degrees equals to 0.8615, and it is equal to h over a, but we know that a equals to 13 units. So sinus of 59.49 degrees equals to 0.8615, and it is equals to h over a, and a is 13. So here we'll multiply this equality by 13 in order to find out the height of triangle ABC. So the height of triangle ABC will be equal, the height that is h equals to 13 times 0.8615, that is equal to 11.2 units. So the height of triangle ABC equals to 13 times 0.8615, and it is equal to 11.5 units. So the height of triangle ABC equals to 11.2 units. So we can write here that the height of triangle ABC equals to 11.2 units. Okay? And again, as I mentioned, the area of triangle ABC, or the area of any triangle, equals to the base of the triangle times the height to the base over 2 . So that is the formula for the area of any triangle, and especially for triangle ABC. So the area of triangle ABC will be equal to the base of triangle ABC, that is 15 units, times the height to the base, that is 11.2 units, over 2. So again, the height AD is the height to the base because it creates 90 degrees with the base BC. Okay, so the area of triangle ABC equals to the base, that is 15, times the height, that is 11.2 over 2. 15 times 11.2 is 168. Over 2. 168 over 2 is 84 square units. So the area of triangle ABC, according to second method, equals to 84 square units. Okay, so the area of triangle ABC equals to 84 square units. That is according to the second way of solving the problem. Now I'll present to you a third way to find out the area of triangle ABC. Okay? So it is a third method. Okay, a third method. Of finding out the area of triangle ABC. Again, I will present to you a third method of finding out the area of triangle ABC. So, actually, according to this method, we will divide triangle ABC to two parts. Actually, we will divide triangle ABC to two right triangles. The first part, after we divide it to two parts, will be the following right triangle. The hypotenuse is 13 units in size. Then it has also one side of 5 units and the other side of 12 units. So actually this is the first part of triangle ABC after we divided it to two right triangles, and this is a right triangle because it obeys to the Pythagorean theorem that states that if you have a right triangle, then the hypotenuse that is squared equals to the sum of the squares of the perpendiculars. This equality must be true for any right triangle. So if this is a right triangle, it must obey to the Pythagorean theorem, that is to say 13 square must be equal to 12 square plus 5 square, otherwise it is not a right triangle. So we'll check if it is right triangle, then it must be true. This equality must be true, so here we will get that 169 equals to 144 plus 25, and indeed 169 equals to 144 plus 29. So in this way we proved that this triangle is a right triangle. The second part of triangle ABC, after we divided it to two right triangles, will be the following right triangle with sides of 12 units. The hypotenuse is 15 units, 15 units in size. And the other side is 9 units in size. So this is the second part of triangle ABC. The second right triangle. We'll check again whether if it is a right triangle or not. If it is a right triangle, then it must obey to the law, to the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, 15 square must be equal to 12 square plus 9 square. So if the two sides are not equal, then it is not a right triangle. So here we will get that 225 equals to 144 plus 81, and indeed 225 is indeed equal to 144 plus 81. Therefore, this triangle is a right triangle. So you can see that if we combine these two triangles together, then we will receive the original triangle, triangle ABC. I can show you that if we combine the two triangles together, then we will get the original triangle, triangle ABC. Okay, so if we combine these two right triangles together, we will get the triangle ABC. So actually those two triangles are the triangles that created by dividing triangle ABC to two parts. Okay, so and this side is 12 units. Okay, this side is 12 units. It is the height of triangle ABC. We proved that this is a right angle, and we have already proved that this is also a right angle. Therefore, the real meaning in dividing triangle ABC to two parts was to show that if the base of triangle ABC is 14 units, then the height to that base equals to 12 units. Okay, so in this way we can easily calculate the area of triangle ABC that will be equal to the base of triangle ABC times the height to the base over 2. So it is 14 times 12 over 2. Okay, again the area of triangle ABC equals to the base of triangle ABC times the height to the base over 2. The base is 14 and the height is 12 over 2. And again, I will emphasize again that by dividing triangle ABC to two right triangles, we showed that if the base of triangle ABC is 14, then the height to that base is 12 units. Okay? So the area of triangle ABC is the base of triangle ABC. This is 14 units times the height, that is 12 units over 2. Okay? So here 12 over 2 is 6. Okay? So in total we get that is 14 times 6, and 14 times 6 equals to 84 square units. 84. So the area of triangle ABC equals to 84 square units. Okay? The area of triangle ABC, according to this, the first method, equals to 84 square units. So we showed in 3 different ways that the area of triangle ABC equals to 84 square units. Okay, so in the next step we will find the radius of the green circle in a second way. Actually, in the third way, we found the radius of triangle ABC in the first way by dividing triangle ABC to 3 small triangles, 1, 2, 3, and by the equality that states that the sum of the areas of the 3 small triangles equals to the area of the big triangle, triangle ABC. And from this equality, that the only variable that is missing is the radius of the green circle, we found out the value of R, and then the area of any circle equals to pi times the radius squared. So we squared the radius and we multiplied it by pi, and we found out the area of the green circle. Now I will present to you a second way to find out the radius of the green circle. Okay, I will present to you a second method to find out the radius of the green circle. Okay, actually we can use the following formula in any circle that is inscribed in a triangle. So in any circle that it is inscribed inside a triangle, the following equality is true. Again, in any circle that it is inscribed inside the triangle, the following equality is true. That the radius of the circle that is inside the triangle equals to the area of the triangle that contains the circle over the semi-perimeter of that triangle. Okay? Again, the radius of the circle that it is inscribed in the triangle equals to the area of the triangle over the semi-perimeter of the triangle. And here we have the green circle that is inscribed inside triangle ABC. So we can use this formula that the radius of the circle will be equal to the area of triangle ABC over the semi-perimeter of triangle ABC. Okay? But we have already found out in 3 different ways that the area of triangle ABC equals to 84 square units. Okay? And the semi-perimeter of triangle ABC equals to 21 units. So the radius of the green circle will be equal to the area of the triangle ABC that is 84 square units over the semi-perimeter of triangle ABC that is 21 units. That is to say 84 over 21 equals to 4 units. So the radius of the green circle equals to 4 units. And the area of any circle equals to pi times the radius of that circle squared. And we have already found out that the radius of the green circle equals to 4 units, so we can substitute R in this equality by 4, and so we will get that the area of the green circle is actually pi times the radius squared r equals to 4, so r squared is 4 square. So the area of the green circle equals to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, the area of the green circle equals to either to 16 pi square units, so in terms of numbers, the area of the green circle equals to 50.265 square units. The area of this green circle equals to either 16 pi square units, or in terms of numbers, the area of this green circle equals to 50.265 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this green circle, and we know that the green circle is inscribed inside triangle ABC, and side AB of triangle ABC equals to 13 units, side AC equals to 14 units, and side BC of triangle ABC equals to 15 units. And tangent AB is tangent to the circle at point D. Point D is the launch point, or the point of tangency between the tangent AB and the green circle, and also point side AC of triangle ABC is tangent to the circle at point E. Point E is the launch point between the green circle and tangent AC, or the point of tangency between the green circle and side AC, or tangent AC. And BC is tangent to the circle at point F, or F is the launch point, or the point of tangency between tangent BC and the green circle. And we want to find out the radius of the green circle. First of all, we found the area of triangle ABC, and we defined the theorem of semi-perimeter of a triangle. Actually, the semi-perimeter of a triangle equals to the perimeter of the triangle, that is to say, the sum of its sides over 2. Okay? So, actually, if we have a triangle ABC with sides AB is equals to A, side BC equals to B, and side AC equals to A. Then we have this triangle, triangle ABC, and side AB equals to A, side BC equals to B, and side AC equals to C units. Then the semi-perimeter of this triangle equals to A plus B plus C over 2. Okay. So the semi-perimeter of this triangle, triangle ABC, equals to A plus B plus C over 2. And we calculated the semi-perimeter of our triangle, triangle ABC. The semi-perimeter is actually S. S equals to A plus B plus C over 2, and in our triangle A equals to 13 units, B equals to 15 units, and C equals to 14 units. So the semi-perimeter of our triangle, triangle ABC, equals to 21 units. And we found the area of triangle ABC according to the first method by using the following formula that states that the area of any triangle equals to the root of S, when S is the semi-perimeter of that triangle, S times S minus A times S minus B times S minus C, when ABC is the sides of the triangle. Okay, so in our triangle we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units, and S equals to 21 units. So we have all the variables inside this formula. So we put the data inside this formula, and we found out that the area of triangle ABC equals to 84 square units. Okay, the area of triangle ABC equals to 84 square units, and then we connected together points A. We defined the center of the green triangle as point O, and then we connected together points A and O by a straight line, and we connected together points O and B by a straight line, and then points O and C by a straight line. Then we draw 3 radiuses from the center of the circle to the launch points of this circle, that are points E, D, and F. And we have a rule number 1, that states that a tangent to the circle is perpendicular to the radius drawn to the launch point. So rule number 1 states that whenever you draw a radius that is drawn to the launch point, like this radius is drawn to the launch point D, actually it touches the launch point D. Therefore, according to rule number 1, this radius is perpendicular to its tangent AB, that is to say this angle is 90 degrees and this angle is also a right angle. The same thing is about this radius that is drawn to the launch point E. It touches the launch point E, therefore this radius is perpendicular to its tangent AC, that is to say this angle is a right angle, as this angle also equals to 90 degrees. And the same thing about the third radius that we draw. This radius is drawn to the launch point F. Actually it touches the launch point F. Therefore, according to rule number 1, this radius is perpendicular to its tangent AC, that is to say this is a right angle and this angle also equals to 90 degrees. Okay, so actually we created here 3 small triangles, triangle AOB, triangle AOC, and triangle BOC. And we created equality that states that the sum of the areas of those 3 small triangles, triangle AOB, the area of triangle AOB plus the area of triangle AOC plus the area of triangle BOC equals to the area of the big triangle, triangle ABC, because triangle ABC contains exactly those 3 small triangles. Okay, so the equality states that the area of triangle ABC that equals to 84 units equals to the sum of the areas of triangle AOB plus triangle AOC plus triangle BOC. And what is the area of triangle AOB, this triangle? It equals to the base of the triangle, that is AB, times the height to the base. The height must create 90 degrees with the base. Therefore, the radius is the height of triangle AOB because it creates 90 degrees with the base AB. So the area of triangle AOB equals to the base, that is AB, times the height to the base, that is the radius, over 2. And the same thing about the area of triangle AOC, it equals to the base of triangle AOC, that is AC, times the height to the base. The height is the radius because it creates 90 degrees with the base, over 2. And the area of triangle BOC equals to the base of triangle BOC, that is BC, times the height, that is R, over 2. Okay? So the sum of the areas of those 3 triangles equals to the area of triangle ABC, that is 84 square units. So here the only missing variable that we have is the radius of the circle. So by solving this equality, we found out that the radius of the green circle equals to 4 units. Okay? The radius of the green circle equals to 4 units, and then the area of any circle equals to pi times the radius of that circle. We know that R equals to 4 units, so we can substitute R by 4. And we found out that the area of the circle, the green circle, equals to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay? And then we found the area of triangle ABC in a second way. Actually, we used the law of cosines in order to find out the area of triangle ABC. Okay, according to the law of cosines, it is true in any triangle. That is to say, we can use it in any triangle. C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay? So we implemented the law of cosines in our triangle ABC. We know that A equals to 13 units, B equals to 15 units, C equals to 14 units. And the only missing variable here is theta. And we found out by solving the equality of the law of cosines that cosinus theta equals to 0.547692, and we actually operated the inverse function of cosinus theta, that is arc cosinus theta, that is arc cosinus, in order to find out the value of theta. So we operated the inverse function of cosinus theta on the outcome, that is 0.547962, and we found out that the theta equals to 59.49 degrees. Okay, so after we know that theta equals to 59.49 degrees, it is very easy to find the area of triangle ABC, because we have the sizes of all the sides of triangle ABC. So here we draw a perpendicular BD to side BC of triangle ABC. So this is a right angle and this is also a right angle. And we know that sinus 59.49 equals to h over a. And sinus of sinus of 59.49 degrees equals to h over a, because triangle ABD is a right triangle, so the sinus of any angle is equals to this, the relationship between the side that is in front of the angle over the hypotenuse. Therefore it is A over A over h over A, and we know that A equals to 13 units, and sinus of 59.49 degrees equals to 0.8615. So it is equals to h over A, and A equals to 13 units, so we substituted A by 13. Then we multiply this equality by 13 in order to find out the height of triangle ABC, and we found out that the height of triangle ABC equals to 11.2 units. Okay, when the base of triangle ABC is 15 units, then the height to that base is h, that equals to 11.2 units. Okay, so the area of any triangle is the base of the triangle times the height to the base, to that base, over 2. So the area of triangle ABC equals to the base of the triangle, that is 15 units, times the height to the base over 2. And the height is indeed AD, because it creates 90 degrees with the base BC. Therefore the height is indeed AD, that is h. Okay, so the area of triangle ABC equals to the base of triangle ABC, that is 15 units, times the height to the base, that is 11.2 over 2. So 15 times 11.2 equals to 168. 168 over 2 equals to 84 square units. So we found out in a second way, a second method, that the area of triangle ABC equals to 84 square units. Okay? Then we found in a second method the area, in a third method we found the area of triangle ABC in a third method. In this method actually we divided triangle ABC to two right triangles, and in this way we actually proved that if the base of triangle ABC equals to 14 units, then the height to that base is 12 units. Okay, we divided triangle ABC to two right triangles, and then we found that the height to the base is 12 units if the base is 15 units. And if we combine together those two parts, we will get the original triangle, triangle ABC, that the base of the triangle is 14 units and the height to that base is 12 units. So the area of any triangle, and especially triangle ABC, equals to the base of the triangle over the height over 2. So the base is 14 units and the height to that base is 12 units, and the height is 12 units because of the fact that it creates 90 degrees with the base. So the height is indeed 12 units. So the base times the height over 2 equals to the area of triangle ABC. The base is 14, the height is 12, and so 14 times 12 over 2 is the area of triangle ABC, and the area of triangle ABC is 84 square units. So we found out in the third time that the area of triangle ABC equals to 84 square units. Okay? We found in the third time that the area of triangle ABC equals to 84 square units. Okay? Then we found in a second way the radius of the green circle. In the first way we found the radius of the green circle by dividing the area of triangle ABC to three triangles, and we created the equality that states that the sum of the areas of the three small triangles equals to the area of the big triangle, triangle ABC, because triangle ABC contains exactly those three small triangles. So the sum of the areas of these three small triangles that equals to 84 units equals to actually to the area of triangle ABC that equals to 84 square units. And in this way we found out the radius of the circle, and then we multiplied the radius, we squared the radius, and we multiplied it by pi in order to find out the area of the green circle. So that was the first way, and here I presented you a second way to find out the radius of the green circle. Actually, you can use this formula in any circle that it is inscribed inside a triangle. Our circle, green circle, inscribed inside triangle ABC, therefore we can use this formula this formula states that the radius of the circle that it is inscribed inside a triangle equals to the area of the triangle that contains the circle over the semi-perimeter of that circle. And we have already found out in 3 different ways that the area of triangle ABC equals to 84 square units, and the semi-perimeter of triangle ABC equals to 21 units. So the radius equals to the area of triangle ABC, that is 84 square units, over the semi-perimeter of triangle ABC, that is 21 units. That is to say, the radius of the green circle equals to 4 units. Okay, after we found out the radius of the green circle, it is very easy to find the area of the green circle, because the area of any circle equals to pi times the radius of the circle square, and we already know that the radius equals to 4 units. So we can substitute r by 4 units, and we got that the area of the green circle equals to pi times the radius of the circle square, and r equals 4, so it is pi times 4 square, or the area of the circle equals to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Again, the area of the green circle equals either to 16 pi square units, or in terms of numbers, the area of this green circle equals to 50.265 square units. Okay, thank you very much.